Hey guys, it's Steven from the Green Engineers, and welcome to a new update of the pump. So this pump has been sitting here on the side of the house for a while, so one day it looked at me pretty weird, and I said, oh, I haven't been working on it really, so I decided I wanted to do some more work on it. So um, number one is I'm still a little skittish on that this pump is actually going to load up. So what do I mean by load up? It's actually going to be able to have enough restriction that the pump is actually pushing up against something, even if we have 60 psi of facilities, basically of utilities coming in, 60 psi of utility water coming in. So my actual machine will have very low pressure gauge. I mean, basically just the weight of the water, a foot deep or something like that, or foot and a half deep. So not very much pressure in my system versus a 60 psi. I haven't done the math, but let's say 3, 4, 5 psi gauge, right? So 5 psi gauge in through the facilities here of just, again, like I said, the pressure of the water pushing down on it. And that'll help it pump it up a little bit, but other than that, it won't have any other help there. And then output is, again, this is a 400 to 1 ratio drive from Drelier, like I said. What was it? JL GD400. They have a new name now and a different color, but it's the same thing. And you can see it's taken up some rust on even its supposable stainless steel parts, even on the heads. But it's been relatively closed. It actually looks like I made a mistake and didn't close this end. But both ends of the tube were closed when it was sitting there with these little yellow caps. Today I'm not wearing the safety shoes. A little bit more serious day. Mainly because the business end over here that we're going to be trying is a piece of PLA block with a small hole in it. So basically this is what I'm doing. I have a small little PLA block, and this one actually has a little bit of elephant's foot holding it closed with a tiny little hole in it and a taper. So this is basically a replica of my what's it called? Of my 90-degree adapter. So basically what I did is I took the diameter of the tube and half the area. So this one that you see is half the area of the existing tube. This one's half of that, and this one's even more half of this one. So this one's half of that one sitting there, and this one is half of this one. So this one I'm going to have to see if the water will just punch a hole, because I don't have anything small enough to punch it. I mean, you can see it almost, and also if you put it up to the sun, you can see it. You can see through it. It's so thin that it's transparent. So far I've tested on facilities just right now with no, and then I have the compressor hooked up with just 10 psi. So 10 psi times 400, not including the 60 psi facilities, is 4,000 psi. So 4,000 psi is what we're looking at here, and that's assuming that you have full restriction, that you're able to load up to 4,000 psi, that there is enough resistance to push up against, and that is assuming that your diameter restriction is small enough. So basically what we have here is is pumping this way, and then I have the combiner block. So already just from this loop here, the area is halved, because you go from 2 to 1, and then this is almost equivalent here of going from 2 to 1 again. And this is just a PLA block, fully solid, printed on the MakerBot Method X. So just some PLA Tough that I've had, not the regular PLA, but the PLA Tough. And from the simulation I ran it as ABS. It's going to hopefully survive this again if it's fully loaded, which I don't think is going to actually happen, because I still don't think it's enough restriction, except for my first test. So if you go here and I turn on facilities, like it's shooting pretty dang strong. I mean, it's a laser beam. Probably if I put my hand in front of it. This is with no pressure. This is with no air. This facility's only. I mean, it's already got some pain behind it a little bit. I mean, it's, you know, it's not pressure washer, but that's what we're going to be putting through this. This is basically pressure washer pressure that we're going to be applying through this system, because it's going to be 4,000 psi. So I have my safety glasses on. I have a headset. The air is already plumbed at 10 psi. With this size, we may bump it up to 20 if I'm not seeing enough load up. Otherwise, and maybe even higher. But the next size, probably not more than 10 psi. So right now, 10 psi, and it's ready to go. It's plugged in. I've already set the regulator, and so we're going to go ahead and turn the valve here that lets the air in and see how it loads up. So I got my PPE on. So it looks like my setting is not high enough, so let me adjust and I'll come back. Okay, so I've adjusted. We're up to 20 psi now. Let's see what happens. PPE on. So I think what happened is it just doesn't have enough force to reach all the way to the end from the pressure that's in there to pump the water up. So that's 20 psi. It is indeed cycling. But we don't see any adjustment in the water stream. The valve is fully open. I don't feel any surging, and it doesn't seem like it's opening up the hole anything. The stream is not changing in size, so it's not wearing the hole open. So let's go and bump it up to 25, 30. Okay, so here is 30 psi. It definitely seems like the stream is pointing in an upright direction now. It doesn't feel like it's any higher force. And it doesn't really sound like the pump is straining much either as well. Make sure this guy's all the way open. Facilities is all the way open. So let's try, this is at 30 right now, so this should be 12,000, right? So let's bump it up to 40 and then call it good there. Okay, so this is 40. It's using a lot of air. My compressor's already cycled twice or three times here. I'm not seeing any change in the stream much, or surging or anything. It's not really coming out with any more force. So what I can say here, conclude, is that this is still not small enough a hole. So let's give the compressor a break. And I do have quite a bit of air leaving here. So that is basically why the compressor is cycling so much. Turn out the facilities. So the compressor is cycling so much because it's not using the energy from the air. There's not enough restriction to pump up. So, of course, this is smaller than all of the actual orifice I'm using is smaller than all of these. My final orifice is 5 thou. I may even, just to test this system, I may even buy the largest orifice that they have because I can't print, nor maybe drill, or maybe I'll try to find a drill to drill the smallest hole I possibly can. So, because I actually did this one and one even smaller, and the one that's smaller also didn't resolve, and it's to the point where you can't even see through it. So, what I'll do, let's give the time for a compressor to cool down. I'm going to swap it to the next smaller hole, and let's try that. But I think even, so this next hole is even half of this one. So half of the area of this one. So we should have, I can't remember the equation if it's squared or what's the deal. I'm assuming it's squared with this one. So should have even more resistance. Basically squared the resistance or something. I'll have to look at the equation. I can't remember. But let's go ahead and try the next size. But so far, I mean, no damage here. It's able to shoot this out. And maybe even this next size, maybe you could even cut soft materials, or maybe even the size below this one. So, again, I have a 5 thou orifice. You could barely even see. These ones are 16 times the area, even the smallest one I have. So, we're just seeing what's the point of it loading, when are we going to load up, and then can I estimate what my actual air usage is to determine what type of tank and how often my compressor is going to cycle, etc., all this stuff. So let's go ahead and pause it, swap out the end to the even half of that one, and let's see how that goes. Alright, so compressor set up. We're back down to 10 psi, and we have the new nozzle on. So this is the old nozzle. You can see the taper, and you can see that we don't really have any hole damage. It looks like it's not perfectly circular, but hey, it's 3D printed. But you can see how big this hole is. So this is half of that one that's installed right now, and you can see the difference in the holes in there. So this is 4 times less than this one, and then this is 2 times less than the one that's installed. So air is off. Gave the compressor a little bit cycle. Now theoretically with this it should take way less air because it's going to start to actually give the air's energy. The air is coming out of here with quite a bit of velocity left. So there's quite a bit of pressure left by the time it exits the exhaust. It should be just slowly coming out of the exhaust and using all the energy into this, especially at 30 psi. It's only using maybe a quarter or a fifth the energy. So that's why it's not loading up. That's what I mean by loading up, using the energy from the air I'm giving it to pump up this 60 psi facility. So let's go ahead and turn off facility, and let's see what the beam looks like. So this, actually the beam is not going nearly as far. Let me step it up a little bit. Okay, so funny enough, the beam is actually coming out at an angle. I'm not exactly sure why. I think it's because the hole is not drilled. It's actually coming out at a slight angle, not straight. So let me take a look at this. Yeah, I'm actually not sure. It may be a piece of plastic debris that's in there that's blocking it. But actually that the beam is going less far is actually a pretty good sign, and there may, like I said, there may be a piece of debris blocking a partial of the hole, or the hole is slightly out of round, or something, which is sort of a good sign. So let's see if this leads to any more let's see if this leads to any more of the pump up that the previous one didn't have. Again, not perfectly scientific because I think something's blocking the nozzle. So let's step it up here. And let's engage the compressor here, and let's see what happens. So here we go. Compressor's on, 10 psi. I'm not seeing any change in the beam. Let's pump it up to 20. So here's 20, and it's cycling now. I'm seeing the beam change a little bit, but yeah, it's like way less force now. I mean, it doesn't even, tangles a little bit, but it's actually way less than before, which is interesting. And I don't see it really leaking. It's not really leaking. It's not leaking the pressure out, so let's try bumping it to 30. Okay, so this is a 30 psi gauge. There's still a lot of force on the air here. Okay. I can feel it pulse a little bit. So let's try 40, and then let's go to the next smaller size. Compressor cycle 1. Okay, this is 40. I'm not seeing a super big difference in the beam. I'm seeing it move a little bit when it pulses. But it's cycling, this guy's cycling very, very fast. I'm feeling it kick. So I feel it kick. So it's doing a kick, 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 kick. So it's trying, it's not adding much. So let's try a bigger restriction and give the compressor a little bit time to cool down. Set it back to 10 psi, and let's try the next size smaller. Next size smaller, the facility is going to have to try to clear out that the elephant's foot on the bottom, and then that's all I basically have for now until I can get something even smaller. Okay, I thought this might be interesting watch. First, before we do that, so this is, let me double check. Yeah, so this is the half size hole, and basically it just has a slightly out of round. It's got a flat spot on there. That's why it's doing that spray setup. So that may actually be similar area as this one, but again, this one the printer didn't even resolve. So this is half of that. So now this is 2. So this is normal size, and then this is 2 times, 4 times, 8 times. So this is 8 times smaller. 8 times smaller than the original. 8 times smaller area. So let's turn on the facilities and see if it'll punch that elephant's foot out. Interesting. So it's not enough to punch the elephant's foot out. Let me see if I can get a needle and push a needle through there. Smallest thing I got, and push it through. Okay, so yeah, I just took a needle with a pair of larger, flat, wide head needle nose pliers, and yeah, I was able to push a little hole in it. Interesting that the water pressure was not able to punch through, which is interesting. So that's about as far in as it'll go. And it's a tapered needle. So let's try that. See how that goes. So let me bump back down. Let's turn on the facilities and take a look. And then let me bump back down the compressor and we'll take a look at that. So let's turn on facilities. So yeah, we have an even smaller laser beam now. And it has 0 force behind it. So I have so much pressure drop in here that I feel nothing. So, interesting. Okay, let's decrease the compressor down to 10, and let's start there. Let's go up to 40. And after that, that's all I got for this experiment. I only have these 3. The other 2 didn't resolve at all. So, yeah, let's try it. Alright, so facilities are on. We're back down to 10 on the compressor. Compressor had a little bit of time to cool off. I think that compressor is a 20-gallon tank. It's not a super large compressor, and I think it's got a horse and a horse and a quarter. And it's a V. Yeah, 2-cylinder. Okay. So that was just the influx, and now that 10 psi has to travel all the way down this hose. So it's not super good example of what would happen in actuality, but I'm clearly seeing, I don't know if you guys can see this, but you can see the beam move when the compressor pumps. I'm still getting quite a bit coming out of the end, but let's bump it up to 20 and see how that goes. But so far, very, very convincing. And the beam is so small now. Let me focus in on the exit point. Doesn't really seem like it's going any further, but it's definitely pulsing. So that's this is the first sign that we've seen of this semi loading up. Let me bump it at 20. Okay, so this is 20. So you're actually seeing the beam significantly pulse, and it actually gets straighter. And it does seem like in that short pulse, it does indeed go farther. And it sounds like the cycling is going slower. I still feel quite a bit coming out of here for 10 psi. I think actually what's happening is because the water is coming in at 60 psi, it's, well, I mean that shouldn't be the case because this should be 8,000 psi right now if it's fully loaded, which we're getting there. So let's try 30. But we're getting it. I'm gonna see it start to shoot up fast. So this is 30. And you can clearly see the pulsing effect going on. It's changing from direction to direction. Let's see what it feels like now. So it's definitely way higher force than it was before. But even like right next to it, so this is 30. So this would be 12,000 psi. Equivalent. Let's try 40. Compressor cycled once already. Alright, so this is 40. So interesting enough, it's starting to like aerosol, turn into an aerosol. Where it's starting to, obviously it's losing focus out here as it leaves. And it's opening up, obviously with the pressure when it gets out, it's opening up past the nozzle. But I think once past 30, I think this guy is only absorbing maybe 5 to 6 psi, I think is probably the load factor of the resistance that is here. There's no much more past that. I mean, you can hear how much the pump is cycling. It's just kind of, that's all it's got. That's all the backup it has. And it's cycling very quickly. We don't want it to cycle very quickly. So, obviously it's stabilizing out the pressure here, but not quite to what we want. So, let's go ahead and relieve the strain off of the compressor. So the compressor was also cycling again when I went into the garage, so it's probably cycling a third time now. So yeah, so I'd say so far we've gotten up to somewhere under 10 psi for load, or so that it starts to, or maybe slightly above, somewhere around 10 psi. Let's say 10 psi average is our load factor. Again, the plan is to run this guy at 60 full load. So using most of the energy that is put into the system. So that's 24,000 psi. So I would say we need to decrease significantly. What I may do is I may print one of these guys that takes that orifice, that 5 thou orifice, or I'll buy another orifice. I mean, those orifices are pretty cheap. They're like, the problem is the orifice, I don't have the tip to mount to it. That's why I'm doing it this way. I don't have that tip that mounts that way. So that tip has got a cone. The cone this way, the orifice requires a cone that's tipped outwards. That's a female. So this is a male. This is a male connector here. And then the nozzle has to be a female connector, but on the orifice, the other way around. It's a female. So maybe I can print something that I can adapt the two. So maybe I can put an adapter in between, put the orifice, put the adapter, and then have this guy shoved into both. So it'll adapt the genders printed. Obviously it would be better if it's resin, but I mean this is a little softer than resin. Resin tends to be hard and brittle. It's not even that hard, but and this is a PLA again, like I said, so maybe make it out of ABS so it's got a little bit of give so I can seal on it, and then maybe do 10 to 30 and see if it actually loads up. So I'm going to see what my next experiments are. And actually, I'm kind of feeling it on my hand a little bit. I can feel where the water was hitting, which is interesting. I don't see any marks, but I can feel where it was hitting before. But yeah, right now it doesn't have anything behind it. When it was with the compressor, it definitely had more. So, pretty interesting experiment. Let me cut this together and get it out, and then yeah, we'll figure out what's the next move later on, and probably just keep going, keep loading the pump up, see how much I can load the pump up, see if eventually I start to get some power behind it, where I can cut a loaf of bread, or maybe even this pretty bad penny board, this garbage Chinese penny board right here. Maybe see if I cut this piece of plastic in half, or cut something in half. You know, maybe even a piece of brick. It'd be nice to be able to get to a piece of brick without garnet. Obviously, it's a semi-hard material, but you can maybe cut it. I think any sort of soft materials, plastics, other things would be nice with even garage type orifice. So let's see what I can put together. Let's keep going on the restriction. We're definitely getting closer though. We're getting closer. Okay, I'll see you guys in the next video. Later. Hey guys. So I'm gonna be honest, I lied just a little bit on the last one. I actually printed 4 of these adapters, and you know, I thought that since this last one, you know, I was able to punch a hole in it, semi-okay. Right. It's not even going to focus because it's so close up. But I was able to punch a hole in it with the needle. That I thought, hey, you know, might as well try to do this last one. I didn't really want to mess with this last one first because it's the first one I threaded, and I actually cross-threaded a little bit when I threaded the plastic with a brand new tap. But also because this one barely worked to do the needle, I didn't know if this one was going to work. Now, to be honest, I did punch the needle through, but actually bent the needle in the process. So we'll see how it goes. But you can see, this is 100% facilities. This is 60 psi facilities coming in. Fully open. And it's trickling out. So, the tap is all the way open. Everything is still there. Everything is, you know, I'm not getting any leaks over here. 100% through here. And it's just trickling out. Right? So, this has such a tiny hole that you could barely even see it. Again, let me see. So, let me zoom in, show. So it is half the size of that hole, right? I don't know if you can see that, but it's half the size of that hole. So this is a tiny little hole. And you can see the load that barely it's even struggling for the 60 psi to even go through. So I thought that, hey, you know, let's puncture a hole with a needle, and let's give this one a shot. Now, what I probably should have done, heat the needle up a little bit, press it. But hey, you know. So when I pressed it in, I kept trying to go until it bottomed out, and then I slipped a little bit, and so I bent the needle. So that the tip of that hole is a little bit wonky, but we will be able to see the load up. So again, I actually took everything apart, attached it all again, and I'm going to try this, and actually it's pretty cool that I'm even getting anything to come out. So if we're going to see something load up, it's going to be probably this one. So let's see, let's get a calculation. So the original, right, goes from 2 pumps down to 1, so it's halved, and then goes through this red tube, right? And the red tube is the same size diameter as these other tubes. So the next one's half of that. So that's 4 times when my very first video, when I had both of these firing 2 on each side. So 4 times that. Let me get these so I don't mess with the calculation. So 2 times, let's see these ones, 2 times, 4 times, 8 times, 16 times, 32 times. So this is 32 times the original area of the hole of each of these pumps. So again, 2, 4, 8, 16, 32. 32 times the original size, and technically 16 times smaller than the hole that is 16 times, not smaller the hole, but smaller area than what's in here. right? So if you cut the this one, if you cut the diameter of the hole in half, the area decreases 4 times. So it's not 16 times smaller hole. It's not that big of a difference. Anyways, so we have 10 psi again. Let's go up to 40 psi. This one I left quite a bit more thread on it. Again, it's cross-threaded, so we're gonna see. I'm gonna have my PPE on. We're gonna see if this thing blows off. But it does feel like it's seating okay. It's a little soft on the seat, but that's okay. Let's see. But I have a lot of thread engagement. This is a 9/16 18 thread, so I should have I have almost the whole depth. So I would say it's like 1.5D or so depth of engagement. So you have 10 psi at the compressor. Let's go ahead and cycle it, see what happens. Facility is 100%. Absolutely nothing. You know what? I don't know if I even attached the hose in the back. Let me attach that hose. Okay, so even at 10 psi we have a huge change in the beam, and kind of the kick is gone for the most part. I mean, it's basically a continuous kind of kick now. So let's go ahead and bump it up to from 10 to 20. And you can see how slow but kind of consistent it's going. So it's also letting out way less air here at the end. So this is good. So this is 20. You can see a little bit more of the pulse, but obviously the stream is going way further. The stream was only ending here before, and now it's halfway to the shed. Right? Okay, so let's bump it up. Okay, so this is 30. This is 30 psi, and the pulsing is kind of gone, and the speed is definitely increasing. The velocity is pretty fast, and actually it's stinging a little bit. Yeah, you can actually feel the sting. Feels like small needles, not that bad, but you can see it actually aerosoling. Kind of, it's turning into kind of like an aerosol of these water droplets, but the speed right here next to the nozzle is the main thing that we're worried about, because obviously air, and right now we got a little bit of breeze, so the breeze is coming in and blowing it after it loses its energy here. But I mean, it's got kind of a little sting on some of the sensitive areas of the skin. So let's go ahead. This is 30. Let's bump it up 40. And the compressor always cycled once, so I hear it cycling a second time. And this is way slower now. And it's letting out less air than it was before. Okay, so this is 40 psi. I feel like the velocity is not really increasing, and you hear that the cycling is increasing, so let's just temporarily bump it up to 60 and see what happens. The compressor's already cycled 3 times, so let's just bump it up to 60. So this is 60. Interesting. So I think there's just not enough focus here. You see, it's just kind of we need a longer focus hole. So the hole is not big enough to focus the beam. So now it's like spraying in like a wide tip at this pressure. And again, this is 60. So this would be my operating that I planned, 24,000 psi. Oh, and I do see it leaking on the back side. It's leaking out the back. So you can actually see it pulsing at the back here. See that? So it's actually leaking out the back. It's not able to hold and seal against this. It's funny enough, the plastic is actually semi-warm. Anyways, I think we get the idea. My compressor's already cycled for a 4th time. It's not really designed for a continuous operation, but look at how it is originally, though. I hear it cycling again, the compressor. This is the original beam with 60 psi of facilities. So we're definitely adding to it. So I would say here we're probably loading up to 15-20 psi of the system. Again, we can review the tapes. Basically, when the velocity stops increasing, that's kind of the maximum amount of energy that we could dump, right? So basically, at a point, we can no longer we don't have enough restriction to convert pressure into velocity, where the water is just leaving before we can push on it, because this system doesn't have any valves that open. We're just pushing against resistance. So same thing as blowing into a like if you take your lips and you blow into one of these holes, right? At some point, the hole is too big that when you blow on it, it just goes through, it just goes through. The velocity doesn't really change very much. But here, this one, like, I couldn't even blow through. I didn't even have enough pressure in my lungs to really have my lungs start to deflate, which is good, but not enough to take all of this pressure from the air and dump it into the water. So I would say, yeah, a little bit over 10 psi. Before it was 10. Now I think it's a little bit over 10. We need to keep dropping. We need to keep dropping the orifice size, and obviously this is kind of an experiment. I have no idea if this guy is actually half of the previous one, because it's probably all messed up inside that the printer can't actually resolve a hole of that size. I think this hole is approximately a 64th, less than a 64th in diameter. So very, very small. I think the original tubing is like 85 in diameter. But yeah, this guy is significantly smaller than that. So, right, 1/64th of an inch. So, very, very, very small. Which 64th is like six. I would say 16 thousandths, somewhere around there. And this one you can barely see with the light if you look through. So we're getting close to what that nozzle actually is. Again, the orifice we're going to use is a 5 thou. But yeah, I think next is either try to. I still want to see this thing load up and shoot a beam, right, before I start to invest in metals. But we're starting to get up on the pressure range, right? If we're at 10 psi, we're already at 4. We're already at 10 psi. It's already absorbing 4,000 psi. So, and this plastic is not rated for that type of pressure. So, I may have to go directly to my finished concept of getting this guy to work. But yeah, as we drop down this size, we have less influence of the 60 psi facilities, which is very interesting. And so we're ready to keep going and see where that takes me. So, my cat here, Mr. Meowgie, aka Shop Foreman. I call him Shop Foreman. So he's over here investigating what's going on, it seems. Anyways, so this is where we're at for today. I'm glad that I did try this smaller one. We're able to see a significant difference in velocity, right? Just from the distance here, right? So the distance went from here to, you can see it started to dry over here. So it went a decent, so let's say here we're at maybe 6 inches. 6 inches of distance to, let's see, let's just call one of my feet 1 foot. So 6 inches to, let's say like, actually I wasn't counting, my bad. Let's say like 8-9 feet. Maybe let's bump it down 7 feet. So it went from 6 inches to 7 feet. That's a huge bump in distance and a lot more power increase for sure. A lot more velocity, right? Which is energy, kinetic energy put into the stream to get that velocity to increase that distance. So the only way to do that is to increase your initial velocity. So, there's a lot of atmospheric pressure anyways, outside. So, yeah, so I'll look into what's the next steps. I would like to see this pump loaded up more, but in a safer fashion. Obviously, we did full 60 running PSI here. Wasn't able to load it up any further, but let's see what the next steps are, and we will go from there. Thanks for watching, and I'll see you guys in the next one.